Hi there, in this video we're going to talk about ellipses, mainly the geometric definition, and we're going to learn how to find the major, minor axes, the foci, and the eccentricity of an ellipse. So an ellipse is essentially the set of all points, so the red here on this figure is the boundary. So all those points are the same, the sum of the distances from the foci, F1 and F2 individually. One is called the focus, together they're called the foci. So if you take, for example, this blue line from any point on the ellipse, xy, and you take that distance to one of the focus, and you add it to the distance to the other focus, those distances, the sum of those distances is the same anywhere along the ellipse. So when you look at this black lines, that distance from another point, say x2, y2, so that the distance from that point to F1 plus the distance from that point to F2 is the same as the sum of the blue lines. So those, and that creates the entire ellipse. So those two fixed points are the foci of the ellipse. So what's the equation of an ellipse with center at the origin? So we have two versions. So the graph of each of the following is an ellipse with the center at the origin. And so we have the first one when you have the a, so a is the larger number, a is greater than b. So you have x squared over a squared plus y squared over b squared equals 1. So with the larger number on the underneath the x, this creates a horizontal ellipse. So the major axis is the horizontal axis. So I'm going to say here, major axis is horizontal when the larger number is underneath the x squared. In this second one, notice that I have x squared over b squared plus y squared over a squared. Now notice that a squared, a is still the larger number. So now, now it's underneath the y. So this is going to be an ellipse elongated along the y-axis. So the y-axis is the major axis. So we're going to say major axis here is vertical. So we're going to just look at the numbers underneath the x squared and the y squared, which one is larger. And the larger one, that's where the major axis is. So then the smaller one is called the minor axis. So here, the minor axis is horizontal. Whereas here, the minor axis, the shorter one, is vertical. And the foci are the c and minus c. So the distance from the center of the ellipse. That's what gives us the foci. And so how do we derive this equation? And so deriving the equation of an ellipse, I'm not going to do the whole math because it gets very long and complicated, but you can look in your book or you could probably search for other videos that can show you. But essentially, if you have this distance, call it d1, and this distance, call it d2. So what we want to say, so the equation of an ellipse is that d1 plus d2 is equal to 2a. So where remember this is a horizontal major axis, so this will be minus a and this will be a. So 2a is the length from one, is the length of the major axis. So 2a, let me say here is the length of the major axis. So after we do the distance formula, right, if you do the distance formula for d1, you get the square root of the change. So x minus a minus c, so it'll be x plus c squared plus y minus 0, so just y squared plus d2. So that would be the square root of, and then you do the same thing here. So x minus c squared plus y squared equals 2a. So if we go through this whole thing, we are going to get to this equation. X squared over a squared plus y squared over b squared equals to 1, because we have this I'm using this equation. So again, I'm not going to go through the whole thing, but this is how you will derive the equation. So once we have this, we can look at vertices of the ellipse. So the vertices of the ellipse are going to be plus or minus a and 0 for this one. And in this case, for something like this, we have a horizontal major axis. So if you have a horizontal major axis, the length is 2a. Actually, even for the vertical major axis, the length will still be 2a. The minor axis, the length is 2b. And the foci is plus or minus c, comma 0, where c squared is equal to a squared minus b squared. So this is for a horizontal major axis. Now if I have a vertical major axis, so the second equation of the ellipse, I'm just going to write it real quick over here. So it'll be x squared over b squared plus y squared over a squared equals 1. So in this case, the vertices would be, we're looking at the vertices of the major axis essentially. So in this case, because it's vertical, it would be 0 plus or minus a. The foci, so the 2 will be 0 plus or minus c. Now the length of the major axis will still be 2a, and the length of the minor axis will still be 2b. And c squared is still equal to a squared minus b squared. And so those are the formulas that we can use in order to then graph it, find the foci. And one of the things I talked about was the eccentricity. So what is eccentricity of an ellipse? So the eccentricity is what tells us is a ratio, the ratio of the foci to the vertices, to a vertex essentially, to a, so C to a, that tells us how elongated is this ellipse going to be, or how close to a circle. So by looking at the picture here, notice that if the focus, the foci, are close to the vertices, we're going to get a very elongated ellipse. Whereas if these foci move in closer towards the center of the ellipse, then it's going to not be as elongated, so it's going to resemble a circle. So the eccentricity of an ellipse is the number, the little e equals the ratio of C to A. And so if this is close to 1, meaning C and A are very close to each other, so if E is close to 1, meaning C and A are close to each other, we're going to have a very elongated ellipse. So the ellipse will be elongated. And if E is close to 0, so that means that C is much smaller than A, then this is going to resemble an ellipse. So C is much smaller than A. So another way to say this is C is closer to the center, then the ellipse will be close to a circle. Close to circular. So let's do a couple of examples. I actually have quite a few examples to go over. So let's try some. So our first example, I have x squared over 16 plus y squared over 9 equals 1. And what we want to do is find the vertices, the foci, and eccentricity of the ellipse, determine the length of the major and minor axis, and sketch a graph of the ellipse. So let's start with, I usually look at it and see, okay, make sure that I have a 1, which we do. So we have a 1 there already. And which one is the higher number? So 16. So that means this is going to have a horizontal major axis. So since 16 is greater than 9, we have a horizontal major axis because the larger number is underneath the x. And then I'm going to try to write it in the format that our equation is, right? So it usually is x squared over a squared plus y squared over b squared equals 1. Because then I know, because it's horizontal major axis, my vertices are going to be plus or minus a 0. So what am I squaring to get 16? We're squaring 4. So this is 4 squared plus y squared over, what am I squaring to get 9? So that will be 3 squared. So that means that a is equal to 4 and b is equal to 3. And so now I can find, let's see, so it asks me to find the vertices. So now I can write what those are. So the vertices will be plus or minus 4, comma 0. The foci, so I need to find the c. So foci, remember the foci, because we have a horizontal major axis, this will be plus or minus c, comma 0, but I need to find c. So I'll write it over here. And remember we said where c is equal to, or c squared is equal to a squared minus b squared. And so I already know a and b, so that means that from here I can say c squared is equal to a squared, which is 16, minus b squared, which is 9. So c squared is 7, which means take the square root of both sides, so c equals, and don't forget the plus or minus, anytime you take the square root of something you get plus or minus. So this will be plus or minus the square root of 7, which we already kind of have it there. So the foci are plus or minus root 7 and 0. And what else were we asked to find? So we got the vertices, the foci, the eccentricity, and then the length of the major axis and the minor axis, which is essentially the major axis. A is 4, so the length is double that, so 8. In the minor axis, the b is 3, so the length will be double that, so it will be 6. But let's go to the eccentricity. So the eccentricity, remember the eccentricity we said is the ratio of c to a. So we want to see how close or how far are these. If they're really close, it's going to be a very elongated ellipse. If they are very far apart, it's going to be close to a circle. So the eccentricity in this case is going to be c, so the square root of 7 divided by a, which was 4. And so when you put this in a calculator, we get 0.66, which is closer to 1, so it's going to be slightly more elongated than circular. And then the lengths of the axes. So length of the major axis is 2a. So in our case, it will be 2 times 4, so it will be 8. And the length of the minor axis is 2 times b, which will be 2 times 3, which is 6. And with that, we can graph our ellipse. I'm going to try to do it over here. So it's horizontal major axes. So I'm going to go to -4 and 4. And then vertical minor axes. is at -3 and 3. And so I am really bad at graphing on the tablet here, but bear with me. So this will be our lemon, our ellipse. And so then these are the vertices. And where are the foci? So the foci is plus or minus the square root of 7. So in order to plot that, when you put it in a calculator, I get the square root of 7 is approximately 2.646. So close to, so a little bit before 3. So there's going to be the negative 1, and 1, 2, 3, and there's going to be the positive 1. So I will say this is the square root of 7 comma 0, and this one is negative square root of 7 comma 0. And the eccentricity is 0.66, so we get a slightly elongated ellipse. So make sure that when you graph these, especially in a quiz, that you label your vertices for the major axes, and might as well do the minor axes as well, and the foci. Okay, so here's a second example. So for this one, now keep in mind, we want to have this one, I don't know which one, I don't have the fractions, so I'm going to write both versions. So it can either look like this, or it can look like this, right? The A is essentially the larger number on both of these. And so I just want to see which one is the larger one. So that means I need to have a 1 on the right side. So how can I get that 98 to be a 1? Divide by 98, both sides. So I'm going to divide by 98. Dividing both sides by 98 means dividing each term by 98. So I'm going to have x squared over 49 divided, or 98 and 49 reduces 2, plus y squared, 2 and 98 reduced to 49 on the bottom equals 1. And now it looks more like one of these. So which one? The larger one is under the y, so this is going to have a vertical major axis. And so I'm going to do the same thing that we did in the other one. What am I squaring to get 2? And what am I squaring to get 49? This one may be easier. 7 squared is 49. What am I squaring to get 2 here? 2 is not a perfect square, but I can say is the square root of 2. So it's just not a pretty number, but that is my minor axis. And so now, how do we find the vertices? So the vertices, in this case, we have a vertical major axis. So that means it's going to be 0 for the x and plus or minus 7 for the y. And so you might want to try to graph it right away. So when I see it, I can already see, well, this is going to be 7 along the y. So I'm going to go 7 and negative 7. This is not going to be drawn to scale, by the way. And the square root of 2. The square root of 2 on the x is 1.4 something. So it's going to be this is going to be a very elongated ellipse. And so what that means is, think about the eccentricity then. It's very elongated, so that means that the focus and the vertices, the foci and the vertices are going to be very close to one another. So we should get an eccentricity close to 1. But I'm getting ahead of myself. So we're looking for the vertices, the foci. So remember, the foci is in this case vertical major axis, so we have 0 plus or minus c. So we have to find c, and I know c squared is a squared minus b squared, which means a was 49, and well, a was 7, so 7 squared is 49. B squared is 2 because b is the square root of 2. So I get 47. So c is equal to plus or minus the square root of 47. So my foci are 0 plus or minus the square root of 47, which you can see those are going to be very, very close. The square root of 49 is 7, so the square root of 47 is very, very close to it. So we're going to have a foci very close to there. And the eccentricity, now that I have C, the eccentricity is C over A. So this is going to be the square root of 47 divided by 7. And when you do this one on your calculator, you get 0.979, which notice that is very close to 1. So that means that the ellipsis is very elongated, which we kind of anticipated by just plotting the vertices. And so at this point, we would try to draw our ellipse to the best that we can. And again, bear with me because I am lacking in the art department. I told you. It's just with the tablet, it's a little bit hard. Okay, pretend it's a beautiful ellipse. And so then the foci are going to be over here. And so make sure that you label it. So this will be 0, positive square root of 7. And this one will be 0, negative square root of, 47. Missed the 4 there. Okay, we'll do another example, but I'll record another video for that one.